So in this video, I'm going to talk about what are known as matrix factorizations, or I think a better description, LU factorizations. So what is an LU factorization? Well, just like with numbers, right? With numbers, in certain cases, right? In certain cases, I can take a number and I can factor it as a product. It's the exact same idea. I've got some matrix, and in certain cases, we can write it as a product of two new matrices, and those two new matrices have some special properties. One of the matrices, the matrix on the left, notice that's going to be a lower triangular matrix. And in particular, it's going to be a unit lower triangular matrix. So notice along the diagonals, we have all of these ones. And then that's going to be multiplied by another matrix U, and that's simply going to be in echelon form. Okay, so it says sometimes we can break these matrices up into products of new matrices, is the idea. Okay, so, and let's give a technical definition, and that's what we just said. So a factorization of a matrix A is an equation that expresses A as the product of two or more matrices. So we just saw that. We had a matrix and we wrote it as a product. Okay, so the idea is we can use these matrix factorizations to help us solve these matrix equations AX equals B. And the idea is, what are we trying to do when we solve one of these types of equations? What we're trying to do is we're trying to find that vector X, so that when we use that matrix transformation A, we end up getting that vector B out. And in order to solve that, instead of kind of doing it in one step, we're going to use this LU factorization to help us do it in two steps, but you'll actually see it'll be faster. Okay, so what is the process? And I think maybe not, I don't know, maybe it sounds a little confusing. It's certainly something I think an example will help, and we'll do one. So what is the process? So step one says we reduce A to an echelon form U by a sequence of row replacement operations, if that's possible. Step two says place entries in our matrix L such that the same sequence of row operations reduces L to I. So one question you may ask yourself is, why do we even want to use it? Well, it turns out that these LU factorizations are fast. They turn out to be, they can be much faster in a lot of situations. And in terms of computing power, that's good. That's a good thing. We want fast. Another thing is, for example, you can use these in different types of electrical engineering situations. So, for example, you can use these in circuit design. You can help design circuits by using these LU factorizations. Okay, so to do this, let's just solve a basic one just to get a sense of how we do it. And again, this one won't be the most difficult one in the world, but I think it's a good place to start. So we're going to solve this matrix equation, or excuse me, this equation AX equals B using row reduction and LU factorization. So here we have our matrix A, and there we have our vector B, and we're trying to figure out what does X equal. Okay, so we know how to solve this. We know how to solve this using row reduction, right? We could just hop in here and start doing row reduction. That's one way to go ahead and solve this. So I am going to do that. I'm going to solve it using row reduction, but I'm also going to solve it using an LU factorization. Well, to solve it using an LU factorization, I'm going to find that LU factorization. So let's find that LU factorization now. That'll be our first part. So find the LU factorization. And this one certainly works out a little bit nicely, and I will certainly do another one. Okay, so the idea is, let's just go through this. So let me copy down my matrix A here. We're going to start changing this matrix around a little bit. Okay, so what I want to do to get started, so we're going to do, again, a couple things. We're trying to come up with this matrix U and this matrix L. And I'm going to manipulate this matrix. That's going to help me, eventually at the end of the day, this is going to help me produce my matrix U that I'm going to use. But from my manipulations, I'm also going to find that matrix L. So, okay, so the first thing that I'm going to do is I want to put this in echelon form. Okay, so I'm looking at this first column, and I'm thinking what I want to do is I want to get zeros beneath it, right? I want to get a 0 here, and I want to get a 0 here. So I'm going to do row operations that allow me to do that. And I'm going to keep this one boxed in because it's going to turn out it's going to be important. Eventually, I'm going to use this. I'm also going to use this when I form L. Okay, but so let's do our operations. I'm going to leave the first row alone. So I've got 2, -1, 2. I'm going to leave it alone. So let's try to get a 0 where that -6 is. I think that's not too bad. I could take 3 times the first row, add that to my second row, and that would give me my new second row. So if I take 3 times the first row, so let's see, 3 times 2 is 6 minus 6, that would give me a 0. 3 times -1 is -3 plus 0 is going to be -3. And then 3 times 2 is 6. 6 minus 2 is going to leave me with +4. Okay, so that looks like one row operation. And I also want to get a 0 at that bottom left entry. So to do that, I think I could take -4 times the first row, add to that add to that the third row to produce the new third row. So if I do that, you can check my arithmetic. I got 0, 3, and -3 when I did that. Okay, so far so good. Now I want to keep up this process, so I want to keep trying to get to echelon form. So now I'm looking at this second column. Now it's going to be important. What we're going to do, though, eventually I'm only going to look at the bottom 2 entries. I'm going to take those here in a second, and you'll see. But again, I just want to put this in echelon form. So all I need to do is I just need to get a 0 down here where this 3 is. So I think the operation I can do for that is to take row 2 plus row 3 and produce a new row 3. And you'll see that, again, at the end of the day, the process that I'm performing will, in fact, satisfy those criteria. So I'm leaving the first and the second row alone. Okay, so now I'm just adding row 2 and row 3. So 0 plus 0 is 0, -3 plus 3 is 0. 4 minus 3 is going to be 1. Okay, now normally I would keep going and I would say I want to keep putting things in echelon form, but now if I look at this entry, okay, so notice I'm kind of taking the top, I'm going along the diagonal is what I'm kind of doing. I'm starting along the diagonal and I'm looking at everything beneath that is what I'm doing as I'm moving along here as I put things into echelon form. Okay, so this last one is good. I can stop there because it's my entry in my lower right corner. Okay, so a couple things. What I have now found, this is one thing. This is now going to be my matrix U, okay? So we've now found U. Now the other mystery is how do we construct L? That's the other matrix that we're missing. Okay, so the way that we construct L is we look at these boxed in entries that I have found. Now, we don't just put 2, -6, and 8 in here because we want the diagonals all to be equal to 1. So to satisfy the criteria, I'm thinking, what would I need to do to make this, this 2 equal to 1? Again, I want 1s along the diagonals. I would have to divide every value in that column by 2. That's what's going to go in the first column for L. So I'm going to take every entry. Again, I'm thinking I want this. I don't want a 2. I want a 1. I want 1s along the diagonals. That's what I need at the end of the day. That's my goal. To do that, I could take my first column and divide by 2. So 2 divided by 2 is 1. -6 divided by 2 is going to be -3. 8 divided by 2 is going to be 4. That's going to be my matrix, or the first column in matrix L. And now I do the same thing. So I don't I don't just drop down -3 and 3. That's not what I want. But instead, what I'm going to drop down is, okay, I'm using that same thought process. I'm thinking I want a 1 along the diagonal. So if I have -3 there right now, well, to make that into a positive 1, I would have to divide everything by -3. So if I divide everything by -3, -3 divided by -3 is positive 1. 3 divided by -3 is going to be equal to -1. Last but not least, if this entry was not equal to a 1, I would do the same thing. I would do division, but you'll actually see it wouldn't matter for this one. Now, you may be thinking, what happens above it? Well, if you remember the form, it just turns out that all of these entries just turn out to be equal to 0. And you can show, let's examine, let's evaluate. Let's evaluate L times U. So hopefully we can do this. I'm going to talk through it. So there's L. Let's copy down U. We'll clean this up. So let's perform this multiplication. And let's think, what would we get? Okay, maybe I'll do a couple entries. I don't think I'm going to fill it all the way out. So let's see, I would have 1 times 2, and then the rest of the entries would be zeros, so I would get a 2 there. Maybe we can do it real quick. That's the magic of these, right? So row by column. Notice I would have a 1 times a -1, and then the rest of the entries would be zeros, so I would get a -1 here. And then I would have a 1 times a 2, and the rest of the entries would be equal to zeros. Likewise, -3 times 2, that's going to be -6, but the rest of the entries are going to be zeros again. Let's see, -6. You can keep going through this process of multiplying them. But you can see already, hey, it's looking a whole lot like our matrix A, right? I found all of those values. And if you continue with the multiplication, you'll find the rest of those values as well. So what I'm saying is we have in fact factored A correctly, is what I'm saying. We've now found this correct factorization. Okay, so that is step 1. So again, this is going to be our matrix L, and this is going to be our matrix U. Okay, now let's actually solve those equations both ways, and this is going to be the fun part. So if you're a bit of a masochist, and I know I am, let's keep watching. Okay, so we want to solve that matrix equation, AX equals B. So again, if you jot down our original matrix A, we said again that was equal to, what did we start with here? No negative. So we said we had 2, -1, 2, and then we had -6, 0, -2, and then we had 8, -1, and 5. And our vector B, recall that vector B was equal to 1, 0, and 4. So if we go back to our diagram again, here's X, vector X. We've got this matrix transformation A, and at the end of the day, we're trying to get the output of B. That's what we're trying to do here. Well, we can do this using row reduction. So I guess let's go ahead and do that. So a couple different ways we could do it, and I think largely what I'm going to do is just follow the procedure that we did, previously. So the first thing that I'm going to start off with, I think I'll just take 3 times row 1 plus row 2. That's going to give me my new row 2. So I'm not even going to change the first row, so let me go ahead and copy that one down. So if I do 3 times 2 minus 6, that'll be 0. 3 times -1 plus 0, that's going to be -3. 3 times 2 is 6. 6 minus 2 is 4. And now 3 times 1 plus 0 that's going to be 3. Okay, so likewise, I could take negative 4 times the first row and add to that the third row to get my new third row. So negative 4 times 2 is negative 8 plus 8 is 0. I would have a positive 4 minus 1. That's going to be 3. And then I would have negative 8 plus 5. That's going to be negative 3. And then we would have negative 4 plus 4. That's going to give me 0. So I think that looks so far so good here. Now you could go ahead and do some simplification. I guess we'll go ahead and do that. So if I take, I could divide all of the entries in the first row and make that my new first row. So I'm going to go ahead and do that. So the 2 would turn into a 1. The negative 1 would turn into a negative 1/2. The 2 would turn into a 1. And then the 1 would turn into a 1/2. Okay, so I'm going to go ahead and do that one as well. So the next thing that I'm going to do is I'm just going to take row 2 and add to that row 3 to give me my new row 3. So that would be one thing I could do. So 0, negative 3. Notice there's a lot of steps here, and this is the point. Solving this by row reduction is slow. So if I add row 2 and row 3, 0 plus 0 is 0. I would get another 0. I would get a 1. I would get a 3. Oh my goodness. This is terrible. I'm going to do the same thing though. I'm going to take negative 1/3 and multiply that by row 2 to give me my new row 2. So I'm just dividing everything by negative 3. So that'll turn into a positive 1. This will become negative 4/3. 3 divided by negative 3 is going to be negative 1. Okay, so I want to get a 0 above it. That's why I did it. So I could take negative 1/2. Let me do it over here. So if I take negative 1/2 row 2 and add that to row 1, that could become my new row 1. So really I'm taking this row, multiplying it by negative 1/2 and adding it to this row to just save myself a little bit of writing. So I would get 0 plus 1, which is still 1. I would have negative 1/2. I need to just use positive 1/2. Let me be careful there. I put negative 1/2. Yes, okay. So let me make sure one more time. This does look good. Okay, so my apologies. We need to multiply by positive 1/2. I was looking at the wrong side. So 1/2 plus negative 1/2, that is going to give me 0. And it just shows you got to be careful with these, right? So let's see. If I take 1/2 times negative 4/3, that would be what? Negative 2/3. And I would add to that 1, so that would give me 1/3. That would give me 1/3. And if I take the last step, if I take 1/2 of negative 1 and add to that 1/2, that looks like 0. Okay, so I think this is okay. I think we're almost there. So again, this is why I said if you're a masochist, keep watching. And of course, write these down in more steps. I assume that hopefully the row reduction is not too terrible. Okay, so the last thing I want to do is just get zeros above it. So how could I do that? It looks like I could take, okay, so I could take negative 1/3 times the third row, add to that the first row to give me my new first row. So again, I'm going to leave the bottom row alone. Let's see. So I would get a 0 here. I would still have a 0 here. I would have negative 1/3 plus 1/3. Negative 1/3 plus 1/3 is going to be 0, just like we wanted. And negative 1/3 times 3 is negative 1 plus 0. This looks like negative 1. I left out my 1 again. I knew something was wrong. Okay, sorry. There was a 1 there. And now, last but not least, what do we want to do? Let's get a 0 here. Okay, so I think our last row operation, we could take 4/3 times row 3, add to that row. We can add to that row 2 to get our new row 2. So again, these are just really miserable to do by hand, as you can see. So 0, let me not forget my 1 there. 4/3 minus 4/3 is going to be 0. That's what we wanted. 4/3 times 3 would be 4, and 4 minus 1 would give me 3. So it looks like now we have finally found our solution. It looks like x should be equal to the vector -1, 3, 3 is what I found. Okay, so that's using row reduction. That was row reduction, and that was a lot of steps. So now let's turn our attention to solve using, so now let's use the LU factorization. Okay, so now we're going to use the LU factorization. So let me copy down my LU factorization. So let me copy this down, and I want to make sense out of that diagram that we had a second ago, is what I want to do. Okay, so there's L and U, and we wanted to solve that matrix equation AX equals B. Now, we just found X in one way, and that was via row reduction. We figured out what vector X got mapped to that vector that got mapped to that vector B. Oh my goodness, I cannot talk. So what I'm going to do now, though, what I'm going to do in this case is I'm going to now do a couple things. I'm going to find an intermediary vector. I'm going to find the vector y that gets mapped to the vector B using that matrix transformation L. And then once I know that, I'm going to backtrack. I'm going to backtrack a little bit more and then use that matrix transformation U. So you may be thinking, how do we do that? So what I'm going to do is I'm going to solve this matrix equation Ly equals B. And again, a second ago we were finding X. Now I'm finding this mystery vector Y is what I'm doing. So if I use my matrix L, that was 1, 0, 0, -3, 1, 0, 4, -1, 1, 1, 0, 4. And again, when I solve this is going to find this vector y, is what it's going to do. So let's see if we can't do this real quick. So I've got 3 times row 1 plus row 2. That's going to give me my new row 2. So I'm going to leave the first row alone. So 3 times 1 minus 3 is 0, and then I would get a 1, and then I would get a 0, and then I would get a 3. This is the magic. See how easy that row operation was. Likewise, I can take -4 times row 1 and add to that row 3 to get my new row 3. Well, -4 plus 4 would be 0. 0 minus 1 is still -1. 0 plus 1 is 1. And then I would have -4 plus 4. That's going to give me 0. Okay, so far so good. Next, I want to get a 0 down there. So to get a 0 down there, I don't think that should be too terrible. I could just take row 2 and add to that row 3 to get my new row 3. And if I do that, so the first row I leave alone. The second row I leave alone. And then the third row, so 0 plus 0 is 0, 1 minus 1 is 0, 0 plus 1 is 1, 3 plus 0 is 3. Okay, so now I know that vector y is equal to 1, 3, 3. That's what I found. Okay, so I've now found this vector y, but now I can do just one more step. Now I'm going to solve this this equation. I'm going to think, so before I said L maps what vector to be, now I'm going to think the same thing. I'm going to think u maps what vector to y. And when I find that, that's going to give me x, but that's what we're trying to figure out, right? That's the whole thing we're trying to solve here. So again, now we're going to solve that extra one. We're going to say u maps x onto y. Okay, so if we go to solve this, again, now I'm using matrix U. So let me copy down matrix U. So we're almost there. So there's matrix U. But now I'm going to attach to it that vector y, 1, 3, 3, and now we're just going to do some row reduction. This one was a little bit messier just because I had some fractions. So I think I just did... So to start off, you can do 1/2 of the first row. That's going to give me my new first row. So this is going to be 1, negative 1/2, 1, and 1/2. So I've still got 0, negative 3, 4, 3, 0, 0, 1, 3. Okay, so we're getting there. And again, obviously you don't want to do these by hand, but as the person who is sitting here doing this by hand, this definitely feels faster, even though I'm breaking it up into two separate matrices. So the next thing I'm going to do, I want to get a 1 here. So I'm going to take negative 1/3 times the second row to get my new second row. So if we do that, I'm going to leave the first row alone. And again, if you're watching this, you're a brave person, because again, I know these are not very, very fun to watch sometimes. Okay, so I got 0, 1, negative 4/3, and 3 divided by negative 3 is going to be negative 1. Again, I'm leaving the last row alone. I think we're getting almost there, yeah? So I think the two last things we could do... let me make sure I've got all my numbers correct. I don't want to miss any signs. I'm double checking. Okay, so I think this looks okay. And I think, are we almost there? I think we're almost there. I'm looking at something and something is bothering me. Oh, okay. I think I left out one step here. Okay, there's a couple steps still missing. Okay. So that's my problem, sorry. Not quite there yet. I thought we only had a little bit left. Okay, so I didn't get rid of this negative 1/2 just yet. So let me do that. So I can take 1/2 of the second row and add to that the first row to get my new first row. And if we do that, so I'm going to leave the bottom row alone. I'm going to go ahead and jot that one down. I'm leaving the second row alone, so let me jot that one down. You can check my arithmetic here when I did this. What did I get this to be? So I would still have a 1 here. I would end up getting a 0 there. That's what we wanted. I ended up with 1/3 here. That looks correct. And then 1/2 times negative 1 would be negative 1/2 plus 1/2. I got 0 here. And then I think we had a couple more steps to do to finally put this in echelon form. So I just need to get zeros in those entries. So I could take negative 1/3 times the third row, add to that the first row to get my new first row. When I did that, again, I'm going to jot down the bottom row because I'm done with it. Hallelujah. My new first row, I got this to be just 1, 0, 0. That part is easy. This turns out to be negative 1, which makes sense, right? 3 times negative 1/3 is negative 1 plus 0 is negative 1. And lastly, I'm going to take 4/3 times row 3 plus row 2 to get my new row 2. So that'll be 0, 1, and 0. 4/3 times 3 is going to be 4. 4 minus 1 is 3. So again, this is our vector x. It's going to be negative 1, 3, 3. And lo and behold, right, that's what we found a second ago by doing row reduction. So Again, I'm not saying they're fast, right? I'm not saying it's like by doing LU factorization, it just falls into your lap. But again, as the person doing it, it certainly felt easier. You know, having all of these ones or, in certain places, it just, all of these zeros, the magic is the zeros, right? That makes things a lot more simple to work with. So, okay, that's the idea. We're now done. We have found X as we wanted to do. So I will definitely do another one of these. I'm just going to find the LU factorization for a 4x4 matrix. I will not go through all of this process of verification, but we will go through one more example of showing how to factor a matrix.